Hey guys, welcome back to another video, and today we're going to be taking a look at the leet code question. Check if all ones are at least length k places away. Alright, so the question is pretty simple. Over here we're going to be given an array called nums, and this array is only going to contain either 0 or 1, okay? And we're also going to be given a integer value called k, and basically this k value tells us between two ones there must be at least a distance of k. So for example, in example 1, we have a k value of 2. So that means the distance between any two ones has to be at least 2, okay? So the distance can be 2, 3, 4, 5, all the way up to whatever number there is, okay? So it has to be at least 2. So let's take a quick look at this example, right? So we have 1, 1 at the 0th index, and we have another at the 1st, 2nd, 3rd, 4th index, and there's another one at the 5th, 6th, 7th index, okay? So in this case, how exactly do we come up with an answer? So what you want to do basically is to find out what is the distance between two ones, okay? So in this case, let's see the distance between this one and this one. So the distance between these two is 3, and we're good to go, right? So the distance there is fine because 3 is greater than or equal to k, right? Which in this case is 2. So that's good. Now we have another set of ones, which is right over here. So this one and this one. Now the distance between these two ones is 2, and that is also valid because the value over here, so the distance is 2, which is equal to the k value, and that is also okay. Now one thing that we're also checking for is what is the distance between the very first one and the very last one. So this over here is 6, but realistically we don't necessarily have to check for it. Now why exactly is that? So the idea behind that is pretty simple. So if the distance between the first one and the second one is valid, and in this case the distance between the second one and the third one is also valid, that automatically tells us the distance between the first one and the last one is valid. Now the reason behind that is pretty simple. So over here we have a distance of 2, and that is good for us, right? Because that we have at least a distance of k. Now whatever it is, so this is the second one, the first one is going to at least be one step before this value over here, at least, right? Not considering the k value, it's going to be at least one index before. So no matter what, the first one's distance from the, in this case, the last one's distance is going to be the same. So basically what I'm trying to say out of all of this is that we only want to find the distance between the current one and the one that is right after it. So for example, we just need to check the distance between the first one and the second one. Then simultaneously, we just want to check the distance between the second one and the third one and the fourth one, and so on and so forth, okay? So hopefully you do understand what I'm trying to say, and let's just take a look at another example quickly. So over here, k is equal to 2. So over here, the first one and second one, the distance is 2. Now the distance between the second and the third one is 1. And 1 over here is smaller than k, so we return false, okay? So yeah, so now let's just see how we can code it out, and it should be pretty simple. Okay, so the first thing that we're going to be doing is we're going to be iterating through each of the values. So to do that, we'll go through each of the indices, and the reason we're going to go by index is because we want to find out the distance, and it's going to be a lot easier this way. So for index, in range, length of our numbers, okay? So once we have the index, what we want to do is we want to check if the current number we have is a 1 or not. So to do that, we're going to do if nums index is equal to 1. And if it is, then we're going to end up doing something. Okay, so now that we go inside of this if statement, what exactly are we looking for? So basically, we want to find the distance between whatever value we're currently on. So we want to find the distance between the current one we are on and the previous one that we had. So for example, if we're currently on the second one, we want to find the distance between the second one and the first one, right? Simultaneously, if we're at the fourth one, we want to find the distance between the fourth one and the third one, right? And the reason for that, like I said earlier, is because if the distance between the fourth and the third number are fine, and the distance between the third and the second one are fine, then that automatically means the distance between the second and the fourth one are fine, right? And we don't need to worry about it. Okay, so this is what we're finding, and then compare it, and then we're going to compare whatever this distance is with k. So, and then compare with k. Okay, so to do that, we actually need to keep track of the previous index where we had a 1. So to do that, we're going to have a variable over here called last. Now the question is, what exactly do we give the value for last? So in the beginning, when we reach our first one, there's not going to be any 1 before that. So in that case, we're just going to give it a value of none. And as we go on, we're going to update this value, okay? So in this case, what we're going to do is we want to check if this value over here is less than k. And if it is less than k, the distance, we're going to return false, okay? So let's do that. So to do that, we would have our index minus the last index where we found our 1 minus 1. And the reason we're doing minus 1 over here is pretty simple. So basically, if you look at this, this is at an index 0 and this is at an index 3. So you do 3 minus 1 and that gives you a value of, 3 minus 0 giving you a value of 3. And from that, you're going to subtract 1 because you do not want to count the ones itself, okay? So that's why we're actually subtracting the 1 from it. Okay, so this gives us the distance between the current one and the previous one, and this has to be less than k. And if it is less than k, we're going to end up returning false. But now the question is, what about in the first condition? We cannot do an integer subtracted by a non-value. So what we're going to do is in the very first condition, we're going to check, or in the very first one that we come across, the last should not be equal to none, and this condition should be true. If that is true, then we return false. But if last is equal to none, what we're going to do is we're going to update the last value with the index. And if we do not end up going in this if statement, and even if last is not equal to none, then that means that the distance between these two is greater than or equal to k, and the last or the previous value's 1 index gets updated. So last is equal to index, okay? Now at the very ending, if we do not end up returning false, then in that case, we're going to end up returning true, and that should be it for our solution. Okay, so now let's take a look at the solution in Java. So over here, what we're going to do is we're going to have a variable called count, and the count variable over here is basically going to tell us the distance between the previous one and the current one that we are on. And the reason we're only looking at the previous one is because if, let's say, we're at the fourth one and the distance between 3 and the third and the fourth one is fine, then the distance between the second and the third one is fine. So that automatically means the distance between the second one and the fourth one is also fine, okay? So over here, we're going to have a count, and that's what we're going to be having. We're going to be taking the distance between them. Now, what we're going to do is we're going to have a for loop. Now, inside of this for loop, what we're going to do is we're going to be iterating over each of the numbers inside of nums. So for int nums, okay? So over here, we're getting each of the numbers inside of num. Okay, now over here, one thing that we want to do is we want to check if our number, whatever we're on, is equal to num, okay? Is equal to 1. So if it is equal to 1, then we want to calculate the distance. Now, what if it's not equal to 1? Okay, so if it's not equal to 1, let's just take care of that. So when it's not equal to 1, then in that case, what we're going to do is we're going to increase this count variable that we have. Now, we need to initialize it and give it a value, but we'll get to that. So each time when our value is not equal to 1, that means it is a 0. And when it is a 0, that means that the distance between the previous one and the current one is going to be greater, okay? So in this case, we're going to increase our count by 1. Okay, so we have this. Now we want to go inside of the condition where where our number is equal to 1. Okay, so over here, one thing that we do need to consider for or about is the fact that what happens at our very first one. Now, at the very first one, there is no value of 1 prior to it. So there's nothing we can calculate the distance to. So in this condition, we cannot just return false, right? So that's something we want to consider. So to consider that, what we're going to do is we're going to initialize our count variable over here to be equal to k. Now, the reason we're doing that is if the count is less than k, then that directly means that the distance is not greater than or equal to whatever the k value is, and then we return false. But in the very beginning, by setting the value of the count to be equal to k, what's going to end up happening is that we're going to just ignore it for the first time, and from the next time onwards, we're going to start counting from the value of 0, and the count keeps increasing when we have a 0, meaning the distance between the two ones gets increased, okay? So real quickly, if num is equal to 1, what we want to do is we want to check if the count over here is less than the k value. Now, if the count is less than our k value over here, then in that case, we're directly going to return false. Now, again, real quickly, in the first one that we come across, the count is going to have a value of k. In other words, the k is going to be equal to k. It does not satisfy this condition, so we do not return anything. Now, in this case, what's going to happen now is that we're going to actually have our count and initialize it with a value of 0. So this basically tells us is that once we go to the very first value, the count is now going to be equal to 0, and each time we're going to be calculating the distance between them. And if at any point the distance is less than the k value, then in that case we just return false. Now, if we don't end up returning false in any of these places, so outside of the for loop over here, we're going to end up returning true in that case. So return true, and this should be it for the Java solution.